Welcome to a Mastering the Marketplace video for the Microsoft Commercial Marketplace. When you publish a virtual machine or container offer to the Azure Marketplace, the Marketplace certification team will check your images for security threats, and publishers may find that they've completed all of the steps in deploying a new offer only to be sidelined by a security concern during the team's certification inspection. This module in Mastering the Marketplace covers what you should know as a technologist building compute offers to successfully publish your offer without security concerns. Check out the URL on the screen for more information about container and virtual machine offers, as well as other resources like the slides for these modules and hands-on labs. Now let's see what we'll cover in this module. Firstly, there are some baseline considerations and expectations for compute offers in the Azure Marketplace, and we'll take a look at some of those topics. Next, I'll cover CVEs and malware, what they are, the differences, and steps you can take to avoid each of these things. Then I'll look at the steps you can take before submitting your offer to better ensure you pass security certification the first time. These are essentially best practices for securing your containers and virtual machines. Let's first visit the expectations various parties have for security in the Azure Marketplace. Rightly so, there are expectations for security concerns from all parties involved in a marketplace offer, to include customers, publishers, and finally Microsoft. Now, customers expect the solutions they purchase to be secure and free from security threats. But with compute solutions that run in the customer's tenant, customers are responsible for ongoing maintenance like patching. Now, for ongoing maintenance of images behind marketplace offers, publishers are expected to frequently release new versions with updated security patches. Now, publishers have certain expectations of their own. Firstly, that Microsoft will scan their images for security vulnerabilities in the publish process and even afterward. Reasonably so, publishers may expect that security of Azure's infrastructure lies squarely with Microsoft. Now, just like customers, Microsoft expects publishers to frequently update images with the latest security patches and updates. And lastly, there's an expectation of customers that they will update their offers with newly released images as appropriate. Let's take a look at the continuum of things that are assessed during offer creation and publication processes. Firstly, publishers perform security and network assessments on the images to be published. When the images are ready, along with the rest of the offer is published in an event triggered by the publisher and partner center. Through a series of automated checks, the Microsoft certification team assesses all images for vulnerabilities. After offers and their associated images pass certification, the offer is published into the Azure Marketplace. After that, Microsoft will run vulnerability scans on published images on a regular basis, not just one time during the publication process. And any issues found with the images will be reported to the publisher for remediation. In this next section, we'll see what publishers can do to protect themselves and their customers from security threats. Let's start with malware. What is it? Well, it's code that runs on your compute instance, be it a container or virtual machine. Now, for malware to function, it is installed on the infected system. And although not always the case, it's common for malware to be written in such a way that it can infect other systems beyond the one on which it is originally installed. Next, let's talk about CVEs. Now, CVE stands for Common Vulnerabilities and Exposures. And unlike malware, CVEs can occur even without installing malicious software on a target system. So an example of a CVE may be a vulnerability in the base operating system upon which your image is built. Basically, CVEs are identified vulnerabilities in compute resources that can be exploited by black hat actors. Further, CVEs exploit security holes in operating systems, software packages, and other software found on solution images. Examples of taking advantage of a CVE might include cross-site scripting, pulling sensitive data out of memory, and accessing stored data. It's worth noting that if a bad actor knows about a CVE and exploits it, it is sometimes possible to install malware via the CVE vulnerability. Now, you may go to the URL on your screen for more information about specific CVE incidents. Also, if you're using Microsoft Defender for Cloud to scan your images and a CVE is found, it will link to more information about that CVE instance. So, backing up to the expectations of publishers, what are some of the things publishers can do before submitting their virtual machine or container image? First and foremost, scan your images for CVEs and malware, of course. Now make sure no CVEs are present in the underlying images that you use to build up your container, should you be working with a container offer. There are multiple tools available for this kind of scanning for both CVEs and malware. And one excellent tool you can use is the aforementioned Microsoft Defender for Cloud. And when using Defender for Cloud to scan your images, your results will be as close to that of the certification team as possible. After a publisher submits an image for certification, Microsoft does some extra checking. An automated scanning process is kicked off for compute images looking for malware. Antivirus software is used to examine solution packages for the presence of malware. CVE checks are run on images to assess the security of the base image, including the operating system and other installed components. It's crucial to note that a vulnerability score of 7 or more for a CVE scan will result in an image not being eligible for publication, and it'll get kicked back from the certification team. When using Windows for your base virtual machine image, there are some things you can do to further secure the image. Always use the latest and greatest images to build your solution, and one best practice here is to use the Microsoft base images provided by Azure to build your solution image. You can build on top of those base images and feel reasonably sure that they are secure and up to date with the latest patches. Speaking of that, you want to run Windows Update on the virtual machine before you generalize it. Also, enable BitLocker to encrypt the hard drives attached to the virtual machine. A few more recommendations for securing Windows images include: don't install Windows features that aren't needed for your solution. Doing so merely increases the attack surface for malicious actors. Also, ensure that Windows is set to auto update. Now, for any usernames or passwords on the machine, don't use the default usernames and passwords. And finally, remove all artifacts left over from your install or testing processes to include host files, logs, and security certificates. There are also things publishers can do to protect Linux images. First, just like Windows images, ensure the latest patches are in place for both the operating system and any software used by the solution. Change any needed usernames and passwords from their defaults, and odds are publishers will use the shell when installing software to the base Linux machine. So clear out your shell history before building the virtual machine into a reusable image. And just like Windows machines, remove artifacts added during solution installation or testing, and finally update solution libraries to latest known secure versions. Here are some examples shown on the screen: OpenSSL, the version of Python that you're using, etc. Microsoft provides some tools publishers can use to further ensure they're publishing secure machines and containers. Let's have a look. For virtual machines, publishers can use the Virtual Machine Certification tool. The Virtual Machine Certification tool from Microsoft can help ensure both Windows and Linux machines are free from threats. This is a utility that you install on Windows that helps by scanning virtual machines before they are generalized. Note that this tool runs on Windows, but can be used to help secure Linux machines in addition to Windows. In the Mastering the Marketplace virtual machine course, there is a module on using the certification tool. Have a look at the URL on your screen to find that module. In addition to the Windows Virtual Machine Certification tool, there are ways to automate validation of your images by taking advantage of an Azure service. This technique does require creation of a service principal and creating an access token. But to use it, you simply construct and post some JSON that describes your offer in your VM to the self-test API. And I should have said VM or container here, because when you call the endpoint on your screen, it's the same whether you're checking for a virtual machine vulnerabilities or for container image vulnerabilities. Here's an example of using PowerShell to call the self-test service for a Windows image. And here's a similar script also in PowerShell that checks a Linux image. Note you can even run these scripts from Linux machines since PowerShell is cross-platform. Or you may also invoke the API endpoints using the code of your choice. And PowerShell is shown here just for ease of an example. Here's a look at some of the major takeaways from this module. Before generalizing your virtual machine image and prepping it for publication into the Azure Marketplace, you need to scan it for vulnerabilities, including CVEs and malware. Although there are many tools on the market and even in the Azure Marketplace that you might choose for your vulnerability scanning, Microsoft Defender for Cloud is a good one that integrates right into Azure and provides results similar to those the certification team will use to check your images. And you learned this important point. When scanning an image of any type, a vulnerability score of 7 or higher on any given issue will cause your offer to fail validation during the certification process. Finally, use the Virtual Machine Certification tool from Microsoft to check VMs before publication. Use the Validation API for programmatically checking both virtual machines and container images. Thank you for joining us for another video from Mastering the Marketplace, the learning library where technologists go to get their offer on the Microsoft Marketplace. For more videos, hands-on labs, and sample code, find us at aka.ms/masteringthemarketplace.